There are many ways to embark on an astronomy journey. Well, this is a different way than we are used to after using the small, compact sea stars. These telescopes detect radio waves and produce images using those radio waves. We recently visited the site and thought you might enjoy seeing a different type of astronomy. The drive was long and desolate, but we enjoyed learning about these telescopes and seeing astronomy performed in a different method. The Very Large Array, or VLA, is located in New Mexico, a bit south of Albuquerque. Enjoy.
Welcome to one of the world's most famous observatories. Set on the plains of San Agustin at nearly 7,000 feet elevation, the Very Large Array, or VLA, is a giant radio telescope made of 27 movable dish antennas, each 82 feet wide, arranged in a giant Y shape. It is operated by the National Radio Astronomy Observatory, NRO-DDU. Unlike optical telescopes that collect visible light, the VLA sees the universe using radio waves, signals emitted by stars, galaxies, black holes, pulsars, and cosmic gas clouds. Today, you're not just visiting a telescope. You're visiting a machine built to hear the universe. Taking your first view of the dishes across the plain. They look futuristic now, but construction began in 1973, and the VLA was officially inaugurated in 1980. It quickly became one of the most advanced radio observatories on Earth, NRO-EDU. Each dish weighs about 230 tons, yet can rotate with precision to point anywhere in the sky. Interesting fact, the antennas ride on railroad tracks, allowing them to be repositioned into different array sizes, depending on what astronomers need to study. Imagine building 27 precision scientific instruments in a remote high desert and making them move like chess pieces. That was the challenge. From here, you can better appreciate the scale. The full array stretches across miles. In its widest configuration, antennas can be separated by up to 22 miles. In the most compact arrangement, they cluster much closer together. NRO-DDU. Why move them? Because the farther apart they are, the sharper the telescope's resolution becomes. This technique is called interferometry, combining signals from many antennas to act like one giant telescope. Instead of building one impossible megadish, scientists built many dishes that work together. These giant structures move gracefully, almost silently. Each antenna can turn left, right, up and down with astonishing accuracy. Interesting fact, a radio telescope doesn't take pictures the way a phone camera does. It collects faint radio signals, which computers convert into images and data. So when you see a dramatic color image from the VLA, remember, the colors are often added to represent invisible radio energy. You're seeing science translated into art. The VLA has contributed to some of the biggest discoveries in astronomy. It has helped study black holes at galaxy centers, jets of matter blasting through space, pulsars, the spinning remains of dead stars, birthplaces of new stars, supernova remnants, the structure of distant galaxies. It also played a major role in studying the center of our own Milky Way. Interesting fact, the VLA helped refine our understanding of Sagittarius A*, the supermassive black hole at the center of our galaxy. This place doesn't just observe objects. It helps answer questions about how the universe works. You may feel like you've seen this place before. The VLA became famous in popular culture after appearing in the 1997 film Contact, based on Carl Sagan's novel. In the movie, astronomers using the array detect a signal from extraterrestrial intelligence. That film introduced millions of people to real radio astronomy. And honestly, if there were ever a place on Earth where humans might first hear another civilization, this would feel like it. Interesting fact, scientists at facilities like the VLA do search for unusual signals, but real science is slower, more careful, and usually less cinematic. No dramatic countdowns. Mostly computers, calibration, and coffee. Why build a world-class observatory here? 3 reasons. 1. Wide open land. The plains of San Agustin provide enormous flat space for the array. 2. Dry climate. Less moisture means cleaner radio observations. 3. Low radio interference. Fewer cities nearby means fewer human-made signals. Your phone, car electronics, satellites, and countless devices produce radio noise. Telescopes like this need quiet. That's why remoteness is an advantage. Out here, silence becomes science. Radio waves are all around you. Wi-Fi, broadcast radio, radar, cell signals. But space also produces radio waves naturally. Hydrogen gas clouds emit them. Planets emit them. Exploding stars emit them. Galaxies emit them. The VLA allows humans to sense a universe we could never detect with eyes alone. It's a reminder that reality is far richer than what we directly see. Take one last look at the dishes. They move slowly, patiently, night after night, season after season, listening to ancient signals that may have traveled millions or billions of years to arrive here. By the time some of those waves reached Earth, dinosaurs were long gone. Humans did not yet exist. And now, for a brief moment, they end their journey in New Mexico. In the early years of radio astronomy, scientists learned that discoveries don't always arrive on schedule. Sometimes they happen while someone is eating lunch, checking equipment, or fixing a cable. At observatories like the VLA, astronomers often schedule observation for hours or days, collecting signals so faint they are buried in noise. Then suddenly, something unexpected appears. A strange burst, a source brighter than normal, or an object behaving in a way no one predicted. One famous lesson in astronomy is that many breakthroughs were first mistaken for errors. Pulsars, the rapidly spinning remains of dead stars, were initially nicknamed LGM, short for little green men, because their precise repeating signals seemed almost artificial. Of course, they turned out to be natural objects, but the joke stuck. Imagine working here on a quiet New Mexico afternoon. The dishes are pointed skyward. Computers hum. Someone opens a sandwich. Then an alert appears on the monitor. A source has changed brightness dramatically. Suddenly lunch is forgotten. That's the magic of places like the VLA. Most days are careful routine, calibration, data checks, patience. But every so often, the universe taps scientists on the shoulder and says, "Look at this. That is the wonder of this place. Keep looking up."
This was a fun trip. It was about 2 hours south of Albuquerque. It was kind of out in the middle of nowhere. There were a few towns that we went through, but we're talking small towns, like one gas station and not a nice gas station. And so if you're going to go out there and check it out, please be sure and take precautions and, a good tire, water, snacks, that sort of thing. But it was a fun trip and we enjoyed going out here and learning something new.